We're talking to a GPT-4 model, but how do we make it understand our data? Find out next. Welcome to this video on Streamlit. My name is Kevin Fiesel, and I am the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video of this series, we connected our Streamlit application to a GPT-4 model hosted in the Azure OpenAI service. We were able to ask questions of the model, but because it didn't have any information on our Chicago parking tickets database, we needed to keep those questions fairly generic. To do justice to this topic, we are going to need to go back to the classroom, so I'll see you there. Alright, now that we are back in the classroom, it is time to talk turkey. What I want to do in this video is make the GPT-4 model deployment that I have in place a little bit smarter about my data. Now, I don't have the money or GPU resources to fine-tune a GPT-4 model, so we'll use a much less expensive approach called Retrieval Augmented Generation, or RAG. But before I get to that, let's talk about a slightly easier variant, which is using a meta prompt. I stole this slide image, and the next slide image that I'm going to show, from a Microsoft talk entitled Generative AI for .NET Developers. I've included a link in the description below to where you can grab the slides and other resources for this talk. This image displays the basic idea of what we are going for. Starting in the middle, we have a user prompt. I need warm, waterproof shoes to go on a hike. If you simply ask your GPT-4 model deployment that non-question and expect a reasonable answer, well, you're probably not going to get one. That's because the GPT-4 model deployment doesn't know about your company's inventory and products. The deployment is liable to make something up. In fact, here's what it came up with for me. This looks prima facie like it is fairly reasonable advice. But if your chat agent is spitting that out for end users, it may not be the best outcome, especially because near the end of this block of text, it lists a series of brands. If you happen to be a manufacturer of waterproof shoes and your own chat agent is telling customers to buy a competitor's brand, it's not a great look. That's where we come up with the meta prompt. At the top, we have a fairly straightforward system prompt. We are telling the GPT-4 deployment how it should behave in this interaction. It is an AI agent for the Contoso Trek Outdoor Products retailer. After that, we provide the relevant information that the GPT-4 model will not know on its own. Specifically, we are going to provide information on the products that Contoso Trek manufactures and sells. Armed with that information, the prompt we get back should look less like the one I showed for a generic GPT-4 model and more like the one that we see in the response. The one we see in the response filters us down to items in the product catalog, which is exactly what we want. But this kind of meta prompt comes with a price. For every query, I need to send the entire meta prompt, including all of the products our company sells. That can add up to a large number of tokens in the prompt and may limit how many requests we can accept per minute, as well as increase the price we're paying for Azure OpenAI, or regular OpenAI for that matter. And there is a risk our product catalog is simply too large to fit in a meta prompt in the first place, and we'll just get an error when we try to run the query. Instead, it would be great if we had some way to parse the user prompt, decide which information is most likely to fit with that user prompt, and submit that as our meta prompt. And it turns out we do, using Retrieval Augmented Generation. The idea here is that we take our user prompt as a starting point. Then, before communicating with the GPT-4 deployment, we are going to query over our own data and retrieve results that are similar to the query prompt. This forms the R in RAG. After that, we add those results to our meta prompt, enriching the user prompt with some relevant information from our own systems. This is the A for augmentation. We send that to the GPT-4 model deployment, and it generates a response for us, which is the G in RAG. Combining all of this together, We are using our own data to generate something akin to the meta prompt we saw, but customized for this specific user prompt. That way, we won't need to include as much information with each prompt, and we can handle more user requests per minute without hitting our token limits. But it's not just any kind of data that we retrieve in this scenario. The knowledge base we're hitting needs to be able to interpret our user's text and retrieve information related to that text. You could technically serve this in a standard relational database, but it would be pretty inefficient because ultimately you're trying to solve a text search problem, and there are better mechanisms for text search than what we have in normal relational database tables and indexes. This is where we get to the idea of vector databases. A vector database stores textual information in vector form. To oversimplify the matter, think of a vector as a collection of floating point numbers, and each token fits in a specific point in vector space. One nice thing about vectors is that we do have measures of similarity. That is, how closely related is one vector to another. We can use that as part of our lookup. By converting the user prompt into its own collection of vectors, we can see how well they tie to relevant bits of information we've already vectorized and cataloged. We can pull back the closest matches from our vector database, and that forms the basis of our results. The large language model's job at that point is to discern which pieces of information fit most closely and craft a message response based on that information. When it comes to vector databases, there are quite a few out there, and I'm sure there are more on the horizon. There are some products like ChromaDB, which are explicitly vector databases. In the Azure world, we can use Azure Cosmos DB and Azure Database for Postgres, but I recommend using Azure AI Search for the task. Azure AI Search is built off of Elasticsearch, a great product for searching for text within JSON documents. With Azure AI Search, we get to take advantage of classic keyword search as well as vector search, and that combination tends to work a bit better than either one individually. Speaking of relational databases, I did mention Azure Database for Postgres, as Postgres does have an extension that allows it to become a vector database. I would expect other relational database products to follow suit, though we'll see how well they work compared to explicit vector databases. That's all I think we need to discuss in the classroom, so let's go to the demo and pick things back up where we left off. What we're going to do in this demo is enable the ability to chat with a GPT-4 deployment about our own data. Now, I will warn you up front, the RAG pattern is not a replacement for a relational database. Furthermore, the information we have in our database fits a relational pattern really well. I'm going to sidestep the question of how we can ask the GPT-4 deployment questions about specific data in our tables. Instead, I'll create a summarization of the data model, and we'll ask the service how we might write relevant queries for specific data. To assist in this endeavor, I've created a data folder and added a script to generate Markdown. I've adapted this query from a blog post a few years back by Thomas Williams, which itself is adapted from a few other queries. The exact nature of the query is not that important, but let me copy the text of it and switch over to Azure Data Studio. Here in Azure Data Studio, I'm connected to the Chicago Parking Tickets database. If I run this query, it will generate a set of lines in Markdown format. This includes each table in the database. For each table, we collect information on the column name, data type, and whether this column is nullable. Also, when Daniel Hootmacher put together the database, he was polite enough to add extended descriptions for most of these columns, so we can take advantage of that. After that, I added a couple of extra sections per table. The first is a set of indexes associated with that table, and the second is a set of foreign key constraints. For both of these new tables, I include the associated columns in the appropriate order. For indexes, we can see the index type. In this dataset, there are 3 types of index we will see: clustered, non-clustered, and spatial. We also get 3 checkboxes that describe whether the index is a unique index, if it serves as a primary key, and if it serves as a unique constraint or alternate key. For foreign key constraints, we have the name of the constraint as well as the parent and referenced tables and associated columns. Daniel made our jobs pretty easy in this database by having consistent naming and single column foreign key constraints. Scrolling down to the bottom, we'll also pick up any views in the database, including the definition of the view. We can also see a list of stored procedures and functions, though not the definitions. In this case, it looks like most of these procedures and functions are to prepare the data rather than things we would like to use in regular processing or querying. Okay, so now I have all of this in Markdown format. I can select the line column header, copy everything, and paste that into a new file. As it turns out, I've done that already. Let's switch back to VS Code and open up the Chicago Parking Tickets.md file. We can see that same basic Markdown structure, and if I use the key combination Control-Shift-V, I can see a preview of the file, which is not that relevant to what we're doing, but it is still kind of neat. That's step one down. We have some data. The next thing we'll need to do is make that data available to us in Azure AI Studio. Let's go over to ai.azure.com and visit our studio. In here, I'm going to select the New Project button to create a new project. A project is just a way of tying together different Azure AI operations under a similar name. I'll name this project Chicago Parking Tickets Video. The next thing I need to do is select a hub, which is a set of Azure resources acting as a hosting environment. If I select the Create a New Hub link, we can see what it entails. I need to provide a name for the hub and tie it to a subscription. Then we can either create a new resource group or put the resources in an existing group. I also need to choose a location. If you already have an Azure OpenAI workspace, choose the same region as that workspace. Otherwise, if you're creating a new one from scratch, pick whatever region you want. There's even a neat indicator in the Help Me Choose link. If you select that, it will prompt you to select the models you intend to use. Let's say that we want to use GPT-4o and GPT-4 Turbo. If we select both of these, we get a recommended location of Sweden Central, as well as a few US-based locations. I can choose to use Sweden Central by selecting the button, or I can select Cancel and choose any region I'd like that has Azure OpenAI resources. Below this location dropdown, I have options for connecting Azure OpenAI and Azure AI Search. I'm going to need both of these, and fortunately, I've already created the resources previously. But if you have not, there are handy links to create these as well. As a quick reminder, you do need to be approved in order to use Azure OpenAI in your subscription. If you have not gone through the approval process, I'll leave a link in the description below with more detail on how you can do so. If we wanted to finish this up and create the resources, we could select Next and then create a project. Instead, I'm actually going to select back on this a couple of times because I have a hub already. Let's then select the Catalyxy Services Hub, which is located in East US 2. Incidentally, the bare minimum that a hub creates in your resource group is an Azure AI Hub resource, an Azure AI project resource when you create the project, a storage account, and a key vault. This is assuming that you already have an Azure OpenAI workspace and an Azure AI search service. Let's select the Create a Project button and let it do its thing. This will take somewhere around 10 seconds or so to complete, and once it does finish up, we'll be on the project overview page. On this page, we have some details about the project, including the hub resource, the subscription, and the resource group. We also have a menu on the left-hand side that we can use for the next steps. Specifically, I'm going to show you one way to index your data in a vector database. It is a fairly simplistic method, but it will work for our purposes. First, I'll select Chat from the Project Playground menu. From there, I'll choose the Add Your Data tab. As you can see, we currently have no available indexes, so I'll need to create one. Let's add a new data source. If I select the drop-down menu here for data source, I can connect to an existing Azure AI Search index or create a new index. We can create a new index based on data that we've already included in Azure AI Studio, data that is available in Azure Blob Storage, data that is available in some public URL, or by uploading a local file. I'll choose the Upload Files option. On this page, we can see that this mechanism only supports a limited range of file types, but Markdown is one of them. That, by the way, is why I generated the script in Markdown format. I'll choose the Upload button and then select Upload Files. Let's grab the Chicago Parking Tickets MD file and select Next. On this page, I need to select my Azure AI search service and then create a new index name. I'll call the index CPT Video Schema. I can then choose a virtual machine that Azure will use to shred my data and put it into a vector database. I don't mind leaving this at auto select, but I will briefly show you what it looks like if you choose the Select from Recommended Options radio button. We can see that we're able to use a variety of Azure VM types. And if I go to Select from All options, there are nearly 200 VM types available to us, though not available to me as I don't have any quota availability for the vast majority of them. But that's okay. I'll just switch it back to auto select and let the service choose my VM type. On the next page, we have our search settings. I absolutely want to tick the box to add vector search to this resource. That's how we vectorize the data and use Azure AI Search as a vector database, in addition to its classical capability for keyword-based or semantic document search. We will then need to choose an Azure OpenAI service with a text embedding ADA 002 model. If you don't have that particular model deployment in place, the script will create it for you. In my case, I do already have one, so I'm good with that. Finally, we have the Review and Finish screen. I'll select the Create button, and at this point, we are going to need to wait for a while. Part of this wait time is getting a virtual machine up and running, and then there are steps to review the documents, shred them, vectorize the results, store the results in an index. In preparation for this video, this file took probably around 20 minutes to complete, so you will be twiddling your thumbs for a bit. But thanks to the mighty power of editing, we are going to Thanos snap our way to the end. Or cause half of living things to disappear. We'll figure out which. Okay, if you're still here and the person next to you is still here, congratulations, we've got a search index. We can now start chatting with our data. I'm going to make sure my settings are correct. First, my deployment needs to be GPT-4, as that's what I'm going to use locally. Second, I want to make sure my search type is hybrid, vector, and keyword. There are several options available to us, but this is the one that will typically work the best. To prove that everything works, I'll put in one sample question. What are the columns available in tickets.parking violations? This will take a little bit of time to respond, but we can see information flowing in, including the schema, the extended properties as a description, and the data types. We also have a reference indicator, and I can hit the drop down on that to see all of the references the GPT-4 engine used. In this case, it used part 1 of my Markdown file. By the way, the fact that there's a part 1 indicates that the service shredded the file into smaller pieces. And if I select this link to the Markdown file, we can see that it did, in fact, do that. The good thing about this is it did not need to send 40K of data. Instead, it could just send the small chunk of the file that contained our answer and let the GPT-4 service extract, rephrase, and tidy up the results. This is a quick proof that we've created the index correctly and we can make use of it. Now, let's update our Streamlit app to do the same. Before I can jump into VS Code, however, I do need to get a little more information. I'll navigate to the Settings menu on the left-hand side and then choose the CS OpenAI EUS2 resource group. That will take me to a new page where I can see the CS AI Search EUS2 service. I'll select that. Then I need to grab the URL associated with my Azure AI Search service. This is going to be one of the 3 new secrets that we need to capture. Scrolling down on the left-hand side, we have the Keys menu. In here, I can copy one of my keys. I could use either an admin key, which has access to all of the actions, or I could create a query key and have limited rights. For this video, I will use an admin key just for the sake of simplicity, but I do recommend building query keys whenever you can. Finally, we need the index. If you scroll back in the video some, you'll see the name that we chose, but I don't actually have that capability, I think. So instead, I'll navigate to the Indexes option in the Search Management menu. That shows me all of the indexes and documents we have available. And look at that, we have CPT Video Schema, just as the prophecy foretold. I'm going to copy that name as well. Off screen, I've already added these 3 new secrets to the secrets.toml file, and I've put them in a new section called Search. For obvious reasons, I'm not going to open that toml file, but you will want to make sure that you have these secrets in place. The next thing that I'll do is add the 3 secrets to the Chat with Data page. If you're following along at home, you'll put the URL into the endpoint secret. The API key goes into the key secret, and the index name, which in my case was CPT Video Schema, goes into the index name secret. The next thing I want to do is add a radio button to the sidebar. The reason for this is, when you are in Chat with Data mode, the GPT-4 deployment gets very specific about how it responds to queries. If your search operation does not return any relevant information, you'll get a generic message back saying that the information was not in your data. This is usually a good thing, as it's a way of preventing people from getting dumb, irrelevant, or bad responses from your chatbot. But I do want to retain this capability in my service, so I'm going to give users an option. Either you get the default GPT-4 behavior, or you get the Chat with Data behavior. To do so, I'll add a radio button into the sidebar, like so. We're going to call the result model type, and that will determine whether we want to chat based on the data in our schema index, or if we want the full breadth of GPT-4's capabilities for stringing words together, including in ways that are wrong or don't make sense. With these 2 changes, we are going to need to update handle chat prompt, adding the search secrets as well as the model type. And of course, if I'm changing the function call, I do need to change the function signature. Let's scroll up a bit to the handle chat prompt function. The first thing I need to do is add these new parameters. Then I'll leave the echo of the user prompt alone. That doesn't change at all. What does change is how we want the assistant to behave. Let's hold off for just a moment on what that means, because there is one more function I need to add. If we scroll up even further, we have a function called Create Chat Completion. This interacts with the default GPT-4 service. It's going to stay exactly the same, as this is the right way to interact with GPT-4 by default. But if I want to chat with data, I do need a new function. Let's paste in that new function, and then I'll talk about it. This function does look a lot like the Create Chat Completion function, though it does take in 3 new parameters: the search endpoint, key, and index name. Then, in the chat completion's create function call, after stream equals true, things begin to diverge. We're adding an extra body to our call, and that extra body includes the data sources we will allow our GPT-4 deployment to use. The type is Azure Search, and we have a few parameters. This is where we send in the endpoint and the index name. We also need to authenticate to the service. If I were running this on an Azure VM, I could easily make use of a managed identity to connect to the search service and thereby not need the search API key at all. But because I am running things locally, I'll use the key-based approach. Now that we have 2 chat functions in place, let's go back to the handle chat prompt and finish the job. I am going to replace the assistant message block with the following code. Much of this code is the same as before, though now I'm checking the model type. If we are using the base GPT-4 model, then we'll use the same behavior as in the prior video. We call create chat completion, and for each response we get back, we add it to the full response string and display that, as well as a cursor indicator, to the screen. Otherwise, if we want to chat against the database schema file, we call create chat with data completion and send all of the info we need. Regardless of the path we choose, when we're done, we write out the full response as Markdown and append that full response to session state. I'll admit that I could tidy up this code a bit and remove some of the repetition, But I think it makes sense to include a little bit of repetition here to make it easier to understand what's going on. And furthermore, we are already done with our code changes. Now the next thing to do is to run the Streamlit process. In the terminal, let's make sure that we're in the source directory and enter the command streamlit run index.py. That will open up our Streamlit page and we'll be able to get testing. The first thing I'm going to do is navigate to the Chat with Data page. Then, we'll leave the radio button at its default of using the base GPT-4 model. I'm going to start with a simple question, and that is, what are the columns available on tickets.parking violations? Now, the response that we're going to get back may differ based on luck of the draw. Sometimes I see a message that the GPT-4 model doesn't have access to the database schema for tickets.parking violations. More interesting is, sometimes I'll see a case when the engine will respond and say it doesn't have exact knowledge of your parking violations table, but a normal parking violations table would contain a certain set of columns. And then it spits out what is basically the schema for this table. That's because it grabbed the schema from Daniel Hoopmacher's blog post on the topic. In this case, obviously we see that, well, it didn't have what we were looking for. Anyhow, this is the boring version. Let's switch over to using the schema-aware GPT-4 model, and then I can ask the same question again. This time around, we are going to get back a more complete response that includes information on the columns, their descriptions, and data types. I'll give it a moment to let the message finish displaying, and in the end, we are going to end up with our full column listing. So as we can see, it is slowly streaming in. We have the column name, we have the reference data that Daniel was kind enough to put in for us. We have the data type, and we have whether or not the column allows nulls. Now, one thing that would be really important if we were actually relying on these results would be to verify that this is in fact the schema that we have. I'll leave that be for now, but if you are trying this at home, you might want to perform a quick check just to make sure that all of the columns are exactly what they look like in the table. The reason for this is, any large language model you use is ultimately a language model, not a truth model, not a knowledge model. It can and will get things wrong. Nonetheless, let's move on and ask the next question, and that is, how can I connect the poverty rate and unemployment rate to the data that I'm querying in tickets.parking violations? The correct answer here is to tie the parking violations table to the locations table, and then we can use the zip code on the locations table to join to socioeconomic indicators that are in their own table in the Chicago schema. The GPT-4 engine is usually good enough to understand what needs to happen at a high level, but isn't always good enough to give us the right answer. So let's see what it comes up with here. So we are seeing that it is taking from the tickets.parking violations table and also joining to the Chicago socioeconomic indicators per zip on zip code. The problem is we don't have a zip code on the parking violations table itself. We would actually need to join to a locations table and then could join to socioeconomic indicators. So in this case, we are actually getting back wrong information from our model. It is, call it directionally okay, in the sense that it gives us an idea of where we need to go, but it doesn't get us there because it assumes a column that is not in existence. After that, I'm going to ask a simpler question and ask, what is the name of the primary key on the buildings table, and what columns does this primary key contain? It'll take a moment, but we're going to be able to get our answer directly from the constraints table in the markdown. And we can see has a building ID and a from address. So that it was correct. Now, one last question that I have is a test of how this chat with data model will handle a question outside of its scope of knowledge. I'm going to ask about Grover Cleveland's top priorities in his first term as president of the United States, which ran from 1885 until 1889. If I do run this against my schema-aware model, we can see that it does not have any relevant information and it displays a terse message. This is actually what we want to see. It doesn't opine on political matters. It doesn't touch upon hot-button social issues, whether contemporary or 19th century. And it doesn't care a whit about Grover Cleveland's stance on the importance of the gold standard for a stable currency. But let's switch back to the base GPT-4 model and ask this question again. This time around, we are going to get back a thesis concerning the things that Grover Cleveland found the most important, at least according to the GPT-4 engine and what it has pulled together from various online sources. Now, I'm not going to talk about these because it's not really apropos to the video, but I did just want to show that there is a significant difference between how helpful the GPT-4 agent behaves versus how much more constrained it will behave when we flip that switch and focus on our own data. And there we have it. We have added in a few dozen lines of code and can now ask questions of the database schema, even to the point of helping us write queries to retrieve data. Because of the nature of this data, it would be a challenge to ask questions directly of the data set. Though if I aggregated some responses and simplified the outputs enough, we could save some results in Excel and query it. But if you're going that far, I would probably recommend looking at the Microsoft Fabric Copilot as a possibility. It is rather expensive, but it does have a better capacity of ingesting data and working with it more effectively than what we've shown. In the next video, we are going to extend our capabilities by introducing speech to text using the Azure AI Services speech service. Stay tuned for that. We'll have links and show notes in the description below. And until we see each other in the next video, take care.